Let's practice using logarithmic differentiation to find the derivative of the problem written here. So our function is f of x equals 2x plus 7 to the fourth times the square root of 5x minus 1 all over the quantity x cubed plus 7x to the 2/3. So this is a pretty nasty rational function. If you were to try to do this just using like the product rule, quotient rule, chain rule, and power rule, you could do it, but it'd be really tedious. But fortunately, logarithmic differentiation allows us to take the derivative of functions like this a lot easier. So what we're going to do is just take advantage of the properties of logs to allow us to rewrite this function in a way that's easier to take the derivative. So often when using logarithmic differentiation, people like to start by rewriting the function as y equals. And you don't have to do this, it just makes the notation a little bit nicer. Okay, so I'm going to write y equals my function. Okay, and then the first real step of logarithmic differentiation is to take the natural log at both sides of the equation. So natural log of y equals natural log of this whole expression, 2x plus 7 to the fourth times the square root of 5x minus 1 over x to the third plus 7x to the 2/3 power. Okay, so why did I take the natural log of both sides? Well, it's so I can use the properties of the natural log to write this in a little bit nicer way. So remember, there's a few nice properties about logs or natural logs. So the natural log of a times b, I can separate that into the natural log of a plus the natural log of b. Or if I have the natural log of a divided by b, I can write that as natural log a minus natural log b. And then finally, if I have like the natural log of, we'll say x to the a, you can pull that exponent out front and make it a coefficient. So this would become a natural log of x. So we're going to exploit these really nice properties of the natural log. Okay, so I need to rewrite the right-hand side. So I have a product in the top. That's going to become a sum, and then this quotient has become a difference. But let me write it out step by step so that you can clearly see kind of the order of operations. So the first thing we have here is a quotient. So let's make the quotient subtraction. So I have the natural log of 2x plus 7 to the fourth times the square root of 5x minus 1 minus the natural log of x to the cube plus 7x to the 2/3 power. Okay, now what I can do is in this first natural log, I can separate this product into a sum. So ln y equals ln of 2x plus 7 to the fourth plus ln of 5x minus 1 to the 1/2. So notice that I rewrote that square root as a 1/2. And that's going to make it easier for you to see the exponent. Minus natural log of x cubed plus 7x to the 2/3. Okay, the last thing I'm going to do is I'm going to pull all my exponents and make them coefficients. So this is going to become natural log of y equals 4 natural log of 2x plus 7 plus 1/2 natural log of 5x minus 1 minus 2/3 natural log of x cubed plus 7x. Okay, so I've completely expanded the natural log, so I'm done at this step. So the next step, after you've completely expanded everything, is to take the derivative of both sides of the equation. Now when you take the derivative of both sides of the equation, you need to remember to use the chain rule. And that's going to be important actually on both sides of the expression. So on the left-hand side, I have the natural log of y. So here you're going to have to remember a little bit from when you learned about implicit differentiation. So y is a function of x. Okay, so when I take its derivative, I need to remember the chain rule. So what do I mean by that? So the derivative of natural log of y, well, I'm going to have 1 over y to start out with. But then I need to multiply by the derivative of y. And the derivative of y is a function, well, y is a function of x, so its derivative I could write as dy dx, I could write it as y prime, I'm going to write it as y prime in this case. Okay, so that's implicit differentiation and the chain rule in action there on the left-hand side. Equals. Okay, so the right-hand side, I need to take the derivative of all of these natural log expressions. So remember, in general, the derivative of the natural log of x is 1 over x, but of course, these are functions of x, so it's going to be 1 over that function and then times the derivative of that function. So here, I'm going to get 4. Okay. I'm going to have 2x plus 7 on bottom. And then I need to multiply by the derivative of 2x plus 7, which is 2. So I'm just going to go ahead and put that on top. Okay, and then plus 1/2, 5x minus 1 on the bottom, times its derivative on top, its derivative is 5, minus 2/3, x cubed plus 7x on the bottom, times its derivative, which is 3x squared plus 7. Okay, I'm going to clean this up just a little bit. So on the right here, I've got y prime over y. I'm just going to multiply these coefficients into their respective parts. So in this first term, I have 4 times 2, so I'm going to make that an 8 on top. With this 1/2, I'm going to keep the 5 on top, and I'm going to just distribute that 2 into both terms in the denominator and write it as 10x minus 2 minus 2/3. Okay, so I'll do the same thing here. And you could leave it factored out if you want to. It's really up to you how you want to keep track of all these terms. But if I distribute that 2, I would get minus, let's see, 6x squared plus 14 over 3x cubed plus 21x. Okay. We finished taking the derivative now. The next step in this process is you want to solve for y prime. So you're ultimately looking for the derivative. So I want to isolate that y prime. And I'm going to do that by multiplying y to the other side of the equation. So that's simply going to look like this. All of what I used to have in parentheses times y. Okay, now for the last step. This, of course, doesn't look very nice. Y prime equals some expression involving x's times y. But luckily, we know what y is. Y is just our original function. So I'm going to simply substitute y prime equals all of this, 8 over 2x plus 7 plus 5 over 10x minus 2 minus 6x squared plus 14 over 3x cubed plus 21x times y. Okay, so I don't remember what y is, so let's go look. So 2x plus 7 to the 4th. Square root of 5x minus 1 over x cubed plus 7x to the 2/3. So perhaps there could be a problem where this would be easily simplified, but usually it's going to be pretty messy, so you'll probably just want to leave it in this form. And this is my derivative. which is also f prime of x. So this is how you do the process of logarithmic differentiation.